Good day, students. Now continue our video lessons. Already we studied the numeric series. Now consider the D'Alembert test for convergence or divergence of the numeric series. Investigation. Our topic is investigation of numeric series for convergence, divergence, divergence, with the help of the D'Alembert. A capital is written in the following form. D'Alembert or ratio test. It is in Azari is D'Alembert nispet alametinin kömeğiyle ədədi sıranın yığılma dağılmaya göre araştırılması. In Russian, исследование числового ряда на расходимость с помощью признака D'Алembert или признака отношения. Consider the following numeric series: x1 plus x2 plus x3 plus etc. plus x sub n plus x sub n plus 1 plus etc. It is the general term and its consequent term. For x n plus 1, x sub n is the previous term. Now give the D'Alembert test itself. First point. This test consists of 3 points. First point. If limit of x sub n plus 1 over x sub n when n tends to infinity is less than unit, then we have convergence. If limit when n tends to infinity of x sub n plus 1 over x sub n is greater than unit, then we have divergence. And finally, if limit of x sub n plus 1 over x sub n, if when n tends to infinity is equal to unit, then we have the indeterminate case. indeterminate case. If limit is less than unit, then we have convergence. Convergence in Nazari yığılma, in Russian сходимость. If the indicated limit is greater than unit, then we have divergence. Divergence in Nazari is dağılma, in Russian is расходимость. And if this limit is unit, then we have the indeterminate form. In Azeri, indeterminate case. In Azeri, it is very müəyyən hal. In Russian, неопределенный случай. Then continue. Then consider the corresponding lessons on the application of D'Alembert test. Now let's consider the first example, example 1. Investigate the given series, series for convergence, divergence, by the D'Alembert test. D'Alembert test. D'Alembert test is in Nazari D'Alembert alameti, in Russian признак D'Alembert. D'Alembert alameti. Признак D'Alembert. Признак D'Alembert. Now consider example. For example, 1 plus 4 over 2 plus 7 over 4 plus 10 over 8 plus etc. It is the numeric series, and we must the type of convergence, divergence with help of the D'Alembert test. Solution. Rewrite the given series in the following form. Represent the first term unit in the expression of fraction. It is 1 over 1 plus 4 over 2 plus 7 over 4 plus 10 over 8 plus etc. Then consider only the numerators. The sequence of numerators. 1, 4, 7, 10, etc. The given numerators are the terms of the arithmetical progression. What is arithmetical progression? Arithmetical progression in Nazari adadi silsile, in Russian the arithmetical прогрессия. Are the terms of the arithmetical progression, arithmetical progression. Arithmetical progression. In other it is adadi silsile. In Russian, арифметическая прогрессия. Then remember the formula of the general term of the arithmetical progression. Here first term is unit, A1 is unit, and D is the difference of arithmetical progression. Difference of arithmetical progression adadi silsilenin farkı. And in Russian it is разность арифметической прогрессии. And D is 3. Then use the formula of general term. A sub n is A1 plus n minus 1 multiplied by D equals 1 plus n minus 1 multiplied by 3 equals 1 plus 3n minus 3, and finally it is 3n minus 2. Here we already obtained the general form of the numerators. A sub n is 3n minus 1. We can verify this formula for the numerators if substitute 1 instead of n. Then for first term we can obtain that 3 multiplied by 1 is 3, 3 minus 2 is 1. Obtain 1. For second term, here we must substitute 2 instead of n. 3 multiplied by 2 is 6, 6 minus 2 is 4. For the second term is 4. Then, for example, substitute 3 instead of n, and for the third term we will obtain that 3 multiplied by 3 is 9, 9 minus 2 is 7. It is the third term, and etc. Then continue and consider only denominators. Second point. Write out denominators 1, 2, 4, 8. They are the terms of the geometric progression. Geometric progression are the terms. Are the terms of the geometrical progression geometric progression. Etc. It is geometric because 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, etc. Geometric progression in Azeri is hendasi silsile. In Russian, geometrическая прогрессия. Then find the general form for all denominators and write out the first term and the common ratio of geometric progression. Common ratio. Now B1, the first term is 1, and Q is 2. Q is here is in English it is named. It is named common ratio. Common ratio. Common ratio. Common ratio. Common ratio. In Azeri it is Сиславрово. In Russian it is знаменатель геометрической прогрессии. Знаменатель геометрической прогрессии. Сиславрово. In English, common ratio. Common ratio. Then remember the general formula of the geometric progression. Geometric progression. B sub n is B1 multiplied by Q2n minus 1. This is formula of the geometric progression. But it was the formula of the arithmetic progression. Then continue. B1 is 1 multiplied by 2n minus 1. And now we have that P sub n is 2n minus 1. This is a general formula of geometric progression, and we can verify this formula for our geometric progression. For first term, for this substitute 1 instead of n. 2 to 1 minus 1 is 0. 2 to 0 is unit. We obtained unit. Then for second term, substitute 2 instead of x. 2 minus 1 raised to minus 1 is 2 raised to 1, and it will give 2. 2 is second. For third term, for this substitute 3 instead of n. 3 instead of n. 2 raised to 3 minus 1, it is 2, and we will obtain 2 squared is 4, etc. Then write the general term of the numeric series itself. Here we have the ratio of numerator by denominator. The general form of numerator x sub n is a sub n over b sub n equals a sub n is 3n minus 2 divided by 2 raised to n minus 1. That is x sub n is 3n minus 2 over 2 raised to n minus 1. It is the general formula of the given numeric series. Then continue. Then obtain the consequent term. For obtaining the consequent terms, we must substitute n plus 1 instead of n is this formula. X sub n plus 1 equals 3 multiplied by n plus 1 minus 2 over 2 raised to n plus 1 minus 1. Then it is 3n plus 1 over 2 raised to n. Therefore we have x sub n plus 1 equals 3n plus 1 over 2 raised to n. And finally, we can already apply the D'Alembert test itself. Limit when n tends to infinity of x sub n plus 1 over x sub n equals limit when n tends to infinity first write the subsequent term 3n plus 1 over 2 sub n sub n divided by x sub n. X sub n is 3n minus 2 over 2 raised to n minus 1 equals limit when n tends to infinity 3n plus 1 multiplied by 2 raised to n minus 1 over 2 raised to n multiplied by 3n minus 2 equals. Then we can simplify by 2 raised to n. Then we have limit when n tends to infinity 3n plus 1 multiplied by 2 raised to minus 1 over 3n minus 2. Then we can transfer into the denominator, then continue. Limit equals limit when n tends to infinity. Here we have 3m plus 1 divided by 3m minus 2, 3n minus 2 multiplied by 2. And then we can take 1 second as a constant factor out of the limit symbol. 1 second followed by limit when n tends to infinity 3m plus 1 over 3n minus 2. If limit variable tends to infinity, then in the limit expression we can retain only the eldest terms in numerator and denominator. In numerator is the eldest term is 3n, and 1 can be removed, and in the denominator the eldest term is 3n, and minus 2 can be deleted. Then we have 1 second multiplied by limit when n tends to infinity 3n over 3n. 3n over 3n is 1. 1 second multiplied limit of 1 when n tends to infinity. 1 is constant number, and the limit of the constant number is the constant number itself. And then we have 1 second multiplied by 1 equals 1 second, and it is less than unit. If the limit is less than unit, it means, according to the D'Alembert test, the given series converges, or this given series is convergent series, etc. We can write answer. The given series is convergent, or the given series converges. The given series converges. Then consider next example 2. Investigate the the given series for convergence, divergence, for convergence with the help of the D'Alembert test. D'Alembert test. The D'Alembert test. Now write the given series. Write out. One plus 3 factorial over 3 plus 5 factorial over 9 plus 7 factorial over 27 plus etc. Solution. First, rewrite the given series in the following form. Here, for comfortable variant, we must rewrite unit as fraction, as ordinary fraction, simple fraction. One is 1 factorial. 1 factorial is 1 over 1 plus 3 factorial over 3 plus 5 factorial over 9 plus 7 factorial over 27 plus etc. Then continue. In the first step, write out the factorial expressions in the numerators. First point, 1, 3, 5, 7, etc. 5, 7, etc. They are the terms of the arithmetic progression. Arithmetic progression. First term is unit, and second term is 3, and difference is 2. And then write out. We can write the general formula for the factorial expressions. A sub n is a1 plus n minus 1 multiplied by d equals 1 plus n minus 1 multiplied by 2. It is 2n minus 1. A sub n is 2n minus 1. Then consider the denominators, and the given denominators are the terms of the geometric progression, whose first term is unit and common ratio is 3. Second, 1, 3, 9, 27, etc. geometry progression. Geometry progression. Progression. Geometry progression. B1 is 1, Q is 3, and B sub n is B sub 1 multiplied by Q raised to n minus 1 equals 1 multiplied by 3 raised to n minus 1. Finally, we have B sub n is 3 to n minus 1. Then obtain the general term of the given numeric series. X sub n is a sub n factorial. It is the factorial expression over b sub n. Then 2n minus 1 factorial over 3 raised to n minus 1. That is, then we have x sub n is 2n minus 1 factorial over 3 raised to n minus 1. Then continue. Then write the consequent term x sub n plus 1. Here we must substitute n plus 1 instead of n in this formula. 2 n plus 1 minus 1 factorial divided by 3 raised to n plus 1 minus 1 equals 2n plus 1 factorial divided by 3 to n. Therefore, we have x sub n plus 1 is 2n plus 1 factorial over 3 to n. Then apply the D'Alembert test itself. Limit when n tends to infinity, tends to infinity of x sub n plus 1 over x sub n equals limit when n tends to infinity. X sub n plus 1 is this expression 2n plus 1 factorial over 3 to n divided by x sub n is 2n minus 1 factorial over 3 to n minus 1 equals limit when n tends to infinity 2n plus 1 factorial multiplied by 3 to n minus 1 over 2n minus 1 factorial multiplied by 3 to n. Here we can simplify by 3 raised to n, the numerator and denominator. And here we will obtain 3 raised to minus 1, and it is 1/3. And therefore we can write 3 in the denominator. Then limit when n tends to infinity 2n plus 1 factorial divided by 2n minus 1 factorial multiplied by 3. Then continue. Continue here. 1/3 is a constant factor, and it can be taken out of the limit symbol. Rewrite 1/3 multiplied by limit when n tends to infinity of 2n plus 1 factorial divided by 2n minus 1 factorial. Then remember the definition of factorial. What is factorial? Factorial is defined only for the natural numbers, and it is the product of the first natural numbers. For example, n factorial is 1 multiplied by 2 multiplied by 3, etc. multiplied by n. But although 0 isn't the natural number, therefore 0 also the factorial exists, and consider that 0 factorial is unit. 0 factorial is unit. We can write here 0 factorial is unit. Though that 0 isn't a natural number. Remember the definition of factorial. Factorial equals 1/3 multiplied by limit when n tends to infinity. It is 1 multiplied by 2 multiplied by 3 multiplied by etc. Until 2n plus 1. And before n plus 1, the numbers 2n and 2n minus unit are situated. Multiplied by 2n minus 1, multiplied by 2n, and multiplied by 2n plus 1. It is the 2n plus 1 factorial. Then 2n minus 1 factorial, it is 1 multiplied by 2 multiplied by 3, etc. multiplied by until only 2n minus 1. Then we can simplify these factors. Equals 1/3 multiplied by limit when n tends to infinity. Here we have only 2n multiplied by 2n plus 1. Then open the parentheses. 1/3 multiplied by limit when n tends to infinity of 4n squared plus 2n. Here we can take only the eldest term, which is 4n squared, and remove the second term, 2n. Then we have 1/3 multiplied by limit when n tends to infinity of 4n squared. Then also we can take 4 out of the limit symbol. We have 4/3 by the limit of n squared when n tends to infinity. If n tends to infinity, the n squared is also also tends to infinity, because infinity squared is also infinity. 4/3 multiplied by infinity is infinity, but infinity is greater than unit. It's greater than unit because it is infinity, and it means our numeric series diverges, or is the divergent series. We can write answer. The given series is divergent, or the given series diverges. The given series diverges. In Azeri çiz verilen sıra dağılandır veya verilen sıra dağılır. In Russian, данный ряд расходящийся или данный ряд расходится. Then continue. Please finally rewrite your homework. Investigate the following series for convergence divergence with the help of the D'Alembert test, which is first series and it is second series. It is there are the factorials in the denominators. Our lesson ended, and goodbye, students. Good luck.